What are we going to do today? So the objective of today's lesson is just to find the net forces that are acting in an object in the x and the y axis. So forces that are acting on an object in the 2 dimensions. How are we going to do that? And then you have a problem over there. You have an object that is not resting, that is on a surface, and 2 forces has been applied. One to the right that is equal to 10 newtons, one to the left that is equal to 15 newtons, and then you need to find the net forces that are acting in the x and the y axis for these objects. When you are solving problems like this, what is your first step? Your first step is just to draw a free body diagram. That's what I'm going to do right now. First step, you have to draw a free body diagram. And you know that in a free body diagram, you're going to be representing all the forces that are acting on that object. So I have my y-axis over here, x-axis over here. Remember that for the free body diagram, you have to isolate the objects. My object is going to be represented here by the origin of the coordinating system, and then I'm going to start analyzing the forces that are acting there. Okay, so I have the gravity force that is acting down. I have, normal force, because over here I have a surface, and according to Newton's third law, for every action there is a reaction force. So if my object is applying a force on that surface is exerting the same force upwards. Then I have a force over here equal to force 1 that is equal to 10 newtons, and I have a bigger force over here to the left equal to 15 newtons. That is your free body diagram. You were analyzing all the forces that are in there. But that's not what you want. What do you want? You want to find the net forces. How are you going to do that? Second step, analyze all forces acting in the axis. X and Y axis. And I'm going to start with the X axis. Okay. Continue with this. Okay, so I'm going to start analyzing the forces in the X and the Y axis. But I'm going to start on the X axis. I'm going to start with the force in the X axis. And then you have to look back at your free body diagram. Look at the free body diagram. Are the forces acting in the same direction? No. So how are you gonna find the net forces in the X axis? Is gonna be equal to the sum of all forces in the X axis. That's the net force. You have force 1, which is positive, okay, because it's to the right, plus, remember that this sign over here means sum, plus the force that is acting in the opposite direction. See, the force is acting in the opposite direction, you have to put a negative in front of that. That's gonna give you the net force acting in the x-axis. Okay, so the sum of the force in the x-axis, you have 10 newtons plus negative 15 newtons and that's your net force in the x-axis. Miramos what that negative means. That the object has been pulled more to the left than to the right. Meaning that the motion of the object is gonna be to the left. And why to the left? Because when you analyze, when you apply that force in that object and you push that to the left, you have to apply your common sense. The object is gonna move up and down. No, it's gonna move left or right, okay, depending on the forces that you are applying. Okay, so if you want to analyze now the sum of all the force in the y-axis, since this object is now moving up and down, all the forces in the y-axis are gonna be equal to 0. So the net forces, they are gonna be equal to 0. Meaning, when you analyze this, okay, you have the normal force, which is positive because it's up, plus the gravity force, which is negative because it's going down. And as you can see over here, the normal force is gonna be equal to the gravity force. How you gonna find the normal force over here is the mass of the object multiplied by the acceleration of the constant, the gravitational acceleration. It's a constant. This number over here is 9.8 meters per second squared. Do we have to do that now? That depends on the problem. If they are asking you for the force, then you will do that. If they are asking you for the net forces, the only thing that you're going to do is just to analyze the forces in the different axes. Questions about that? No. Miramos. What's going to happen over here? Okay, let me change this. A ver. Because that's too easy. But what's gonna happen over there? That block is gonna move. I don't know. You know what I don't know? Because if I am in a flat surface, if I apply a force equal in magnitude but opposite in direction to another force that was applied to the object, they're gonna cancel. But that's an incline. An incline. Meaning that I have components for the gravity. The component of gravity in the x-axis is gonna help the force that is pushing down. I don't know. So that's why you have to create your first step. What is your first step? You have to draw a free body diagram. Let me put it here. My free body diagram. Y-axis. What happened with the free body diagram? That the gravity force is always acting down. Acting down. And the normal force is always acting perpendicular to the surface. Is my gravity force equal to the normal force now? I have a force acting in this direction. I'm gonna call this F2. I'm gonna call this F1. Miss Ramos, what's gonna happen here? That block is gonna move up or down. I don't know. Remember that my block is over here. And now I have a gravity force that is applied at an angle. What do I have to find? The components. So I'm gonna use another color. Which is in this axis, the gravity. By looking at that free body diagram, is that object moving up? Which way is that object moving? Okay. And I don't care, okay? I don't care about the net forces on the y-axis because you have to use your common sense. If you have an inclined plane, and we were learning about simple machine, you know what an inclined plane is. You are putting a refrigerator on top of the truck and then you're using a ramp. The refrigerator is moving up and down. So you know that in the y-axis, okay, the sum of all the forces are gonna be equal to 0. You know that because that refrigerator is not moving up and down. So the normal, in this case, is gonna be equal to the component of the gravity in the y-axis. That, by the way, in that case, is gonna be related to the cosine of the angle. So it's gonna be the mass multiplied by the constant multiplied by the cosine of 30 degrees. See that? That's the normal force. Because now the normal force is gonna be equal to the component of the gravity force in the y-axis. Now, in the x-axis, which is in the axis that my object is moving, so I had a force 2, which is positive, plus the F. Oh, no. I make a mistake. You didn't say anything. Look over here. I make a mistake with my notation, and you didn't say anything. This is over here F2, and I have over here F1. F1 is positive plus F2 in the opposite direction plus in the opposite direction too. And I'm going to start manipulating my equation. If I want to find the sum of all the forces, if the force 1 minus F2 plus the component in the x-axis. This is a given. What happened with this one? Mass multiplied by the constant, but I'm looking for the component Opposite side, sine, ten newtons, 10 newtons. What was the mass of this? 10 kilograms. Multiply. Remember that constant is going to be equal second square times 0.8 meters per second square multiplied by the sine. Did you get that? No, maybe. 0.5 multiply by this, that multiply this, add by that, 59. Did you get that in the calculator? Pretty much, because if you multiply 9.8 by 0.5, that's dividing that by 4 by 2. So it's 4 point something multiplied by 10, 40, 49. Plus 10, you have 59. And then you have to subtract the number and keep the sign of the one with the highest absolute value. Miramos what that negative means. If the object moving to the right, which way is my object moving? See, my object is moving down even though the forces applied are the same. Understand what I'm trying to explain here. Okay. Now, what happened when you have the other way? Instead of going down, you are going, no, instead of going up, you have the other situation. In that situation, the angle of gravity is in there. So you have to find the components. To find the components to analyze which way your object will move. Okay? That's why it's so important to find the net forces on the x and the y axis, because sometimes when the forces is sometimes the object is gonna move at an angle with the surface, but that depends. Questions until here? No? Do you understand that now, Joshua?